Welcome to the South Australian No-Till Farmers Association 2021 webinar series. This webinar with Peter Norwood will explore soil, plant and animal nutrition, and is brought to you by the South Australian Grains Industry Trust and the South Australian Department of Environment and Water. Your host is Callum March.
Introduce now Peter Norwood. Pete's from Full Circle Nutrition over in, I think it's Maffra in Victoria. He works as a consulting agronomist. I'll let him explain more on that, but he's going to go through how the food we grow and eat affects our health and his thoughts on how we can improve our health through better nutrition. So I won't say any more. I'll let Pete jump straight into it and sit back, and I think it'll be a really good talk. So thanks, Pete.
Thanks, Kelp. Thank you very much, and thanks to SANTFA for the opportunity, and thanks for everybody who's taken the time tonight. It's always hard at the end of a busy day to sit down and take the time, but I really appreciate you all coming along and having a listen tonight to what we want to go through. Just a little bit of background on myself. I grew up on a mixed farming operation in Mendura in New South Wales. I went to university at Wagga and did ag science at Charles Sturt University, and then headed out into the wide world and perhaps became a bit disenchanted initially because I thought I'd learn all this stuff at university. It wasn't until I really got out there and got into the wide world that I realised how little I did know. And I was just having a talk to Jerry Butler about that as well. But we now, my wife and I, live and work at Maffra in Victoria, and we're in Gippsland, so we're about 2.5 hours east of Melbourne, in a beautiful little spot here. We've got a major irrigation scheme. It was predominantly dairy, now it's dairy and vegetables. We've also got mixed cropping, beef and sheep, quite a bit of horticulture happening here these days. I do on-farm consulting, do agronomy work. I also do dairy nutrition and ruminant nutrition work. And as Callum mentioned, we also developed an interest and then end up training in hair mineral analysis. So we developed that originally for animals so that we could understand the implication of not providing enough nutrition through the food chain into the animals. But as a byproduct, I ended up with quite a large human health business as well, providing some nutritional insight for people. So I want to share with you tonight a few thoughts. A lot of what I'm going to show you tonight comes from people who are, in our history. As we like to say, we should stand on the shoulders of giants. And I want to just share with you some of the insights that some of these pioneers brought to the table. And then I want to flesh that out a little bit. I want to give you some insight as to how that could be impacting on our own health. And then perhaps then relay it back to what we see within plants and why that may be, and where the bottlenecks might lie. And I get really excited about a lot of these things that I'm going to share with you tonight. So please feel free at the end to ask plenty of questions, and I'll enjoy going through those questions with you all. But I just thought we might start on a bit of a lighter note, if you don't mind.
How old are you? 40. Number of the teeth have decayed cavities in them. Say, you're a fine, big, strong fella. How old are you? 20. You look as though you were a giant. My. Where'd you come from? Labrador. Well, that's the place. The most universal disease in the world is the decay of the teeth. And unfortunately, we have not known the cause until we've gone to the primitive people to find how they prevent tooth decay. Our difficulty is that we are adding too much white flour and sugar and do not get enough of the foods that carry the minerals and vitamins. When the primitive people adopt the food of modern civilization, their teeth decay just as ours do. I've spent several years studying the primitive people in various parts of the world, and I've come as a missionary from them to the people of modern civilization and I beg of you to learn of their accumulated wisdom. And if you do, you too can have strong, healthy bodies without so much disease as we suffer from these days.
I don't know if a few of you have heard of Weston Price, but he was a dentist, and he actually travelled quite extensively. So he ended up travelling all over the world, trying to study different groups of native people, and he actually came to Australia. As you saw, he interviewed the Aboriginal population. He travelled widely, and he really found that there was a lot of people in these populations that had beautiful straight teeth, which he was fascinated by because he was a dentist. And they had no decay, they had strong bodies, but they were eating a very traditional diet. And so he wanted to examine that diet and understand what it was about that diet that actually provided these people with seemingly a different health to our modern supposed civilizations. And when he analysed the foods, he actually found that the food that these people were eating were at least 4 times the calcium and other minerals, and at least 10 times the fat-soluble vitamins. And they were eating things like, butter, fish, eggs, shellfish, organ meats, as an example. And there was often food given to, special food given to the ladies who were looking to start a family, whether they be pregnant or lactating, and also the maturing boys and girls in preparation for their parenthood. And those foods were very rich in fat-soluble vitamins and vitamin D, and nutrients that are often found in animal fats, as an example. So it was a fascinating study that he did. And he found that on a poorer diet, so if they introduced a westernised diet to any of these populations, they often then ended up with poor dentures, and they had poor dental arches and couldn't fit all their teeth within those dental arches because of the lack of nutrition within that Western diet. Then there was Dr. William Albrecht that some of you might have heard of, and some of you may have heard me talk about before. So Dr. William Albrecht was the head of the soil science department at the University of Missouri between about 1910 and about 1960. And he was one of the first scientists to really examine the relationship between soils, plants, animal health, and then also human health. And he asked some incredibly poignant questions, really. And one thing I love about working with farmers is that farmers are so observational. The best farmers always make terrific observations, acute observations, and want to know why those observations are. And one of the questions that Dr. Albrecht asked was, why were the bison in America only travelling from north to south along the 98th meridian, and they never went east to west? They only went north to south. And he discovered that when he started to have a look at all the data from the soil testing work that he did across the United States, that the soils in that north to south pathway, or the Midwest, the food bowl as they call it these days, were excellent. They had good conductivity. The soil fertility was dense. There was lots of calcium and trace minerals in these soils when they mapped them. So absolutely fascinating piece of research that he did. And he actually found, interestingly enough, we always talk about how good it would be to have a bit more moisture, but he actually found that the higher rainfall soils had undergone a lot more weathering and a lot more leaching. And up to 30 inches of rain a year saw an increase in the measurable available calcium, magnesium and potassium, but 20 to 30 inches was optimum. And if you went outside of that, particularly into the coastal regions where there were much higher rainfalls, that there was a real displacement of nutrients in those soils. And so the soils were weathering and breaking down. And he then described that as affecting the proteins and the minerals in the cattle feed, for instance, on these high degree of soil development soils. And at the time when I started reading some of this information, I was doing a fair bit of work in New Zealand, and over there they've got very young soils. They've got glacial soils that are only sort of 10,000 years old. But if you look at that by comparison with Australia's soils, we are a really old, ancient continent, and I often joke that we got the old lemon, and now we're trying to push it pretty hard most of the time. So if we've got soils that are been weathered over time, and Dr. Albrecht was describing this to us back, very early last century, then perhaps there's some opportunities to change both the productivity of our soil and also our animals just by understanding that there's going to be some deficiencies present, obviously. He also, and he actually copped a bit of a hard time for this, but he actually discovered that there was a distinct relationship between the soil health and human health as well. And he did that by studying the draftees from the World War I, and he was looking at their medical records because there were people that were, after failing their physical exams, weren't allowed to enter the army and go off to war. And he wanted to know why they failed their physical exams, and then what reflection that had on their own nutrition. And what he discovered was that they had flat feet. They, once again, as Dr. Weston A. Price had described, they had poor dental arches. And he found that when he went back through the records, in those days, I come from Maffra. If I'd grown up at Maffra, I would have eaten food from Maffra. And so he went to where he noticed that a lot of these draftees came from places like the Appalachians and the Ozarks. And when he went and examined the soils there were these very stony, flinty soils, very thin soils, and they were very, very low in calcium and phosphate, two of the main minerals that are required for healthy bones and healthy teeth. So he did some incredible research and brought it to the table so that people could benefit from that research. He also talked about the cattle and the animals that we all farm, and he talked about them as being better biochemists than we ever will be. One of the questions, if you ever get the chance to have a look at, he asked, there's a little film called The Other Side of the Fence that you can look up on YouTube. It's about a 15 or a 20-minute film, and at the start of that film, he's got a cow trying to stick her head through the fence because she knows there's better quality food on the other side, and the farmer is trying to prevent her from telling him that there's better quality food on the other side by driving her back through the fence instead of asking perhaps a more obvious question. And one of the things he used to talk about was the concrete highways in the US. Anyone who's ever been over there will know that there's, miles and miles and miles of concrete highways over there. And back in those days, they would have, forest land going up pretty close to these concrete highways. And Albrecht noticed that the cattle would come all the way out of the forest, and they would graze right up to the edge of the concrete road, because the concrete was made from a substantial amount of calcium, and it would leach out from the concrete and into the grass and create a more nutritious grass, which the cattle were really desiring. You may have even seen it around your own houses where you've got concrete paths. Quite often the grass is growing a little bit more effectively in that area. He also noticed other relationships. This was one with magnesium. I found this very interesting. He explained that if you had a magnesium deficiency in animals, that there was a possible causal connection with dwarfism or midgets in cattle. And it really struck me because over in New Zealand, they've got very, very low magnesium in their soils and not a lot of magnesium coming through into the plant. We can have a lot of issues with magnesium coming into our plants here as well, but compared to the Kiwis, we tend to have a substantially higher level of magnesium coming through quite often. But over there, I took a photo of these heifers one day. I was driving down the road, and they were 14-month-old heifers, but they were like potty calves. They were just so small, these heifers. And the guy who was driving me around said that they'd be getting joined now. And I said, "Oh, look, you couldn't join them. It'd be cruel. They were so small." And then I saw the bulls, and the bulls weren't any bigger in this particular farm. So they were really struggling for magnesium, these guys. Over here, it's hard to see the reflection because they're not side by side, but our animals were, substantially higher. They were standing up towards shoulder height, being joined at the same time versus, not much more than waist height. So a really substantial difference in these animals, and something that I found fascinating. Right, we'll try this one. Just want to play this little clip here.
One man who pondered these questions was Dr. William A. Albrecht, chairman of the Department of Soils at the University of Missouri. For years, he had studied soils of every type in hundreds of localities, both here and abroad. He had studied the effects of various kinds of soil treatment, analyzed the results of neglect and abuse of the soil. And Dr. Albrecht's research led him beyond the soil itself into the field of animal nutrition. The analysis of feeding tests conducted with various types of feed grown on different types of soil. And eventually he had reached the subject of human nutrition, studying how foods grown on different soils could affect health, growth, and vitality, how the soil itself might contribute to illness. Dr. Albrecht's conclusions, drawn from 30 years of scientific research, are of vital importance to all of us. They may well revolutionize food production methods and bring new health standards to the nation. Says Dr. Albrecht,
if we are to maintain health, our diet must provide us with the basic food elements common in our various foods. These essential foods have, of course, been subject to much talk and a great deal of food education in recent years. However, we have brought to light an alarming and significant fact. It is this: today there is no real way of being sure that we are getting the necessary elements in our diet, even if we eat what seem to be the proper foods. These two bunches of celery look pretty much alike, but this one has plenty of food value, while this one contains not much more real nutrients than a glass of water. The same is true of these other foods. There is no way to tell by appearance which of these has food value. Intensive experimental work during recent years has shown us why two seemingly identical plants may vary so widely in their food value. In learning this, we've discovered why some farm animals fail to grow normally. And such discoveries have begun to show us what is undermining human health. Our loss of health today can be traced directly to the soil. Our farming methods have robbed the soil of vital food elements. And without those elements in the soil to nourish our crops, we cannot live. Let's consider the problem. When insect pests attack our crops, we can see the enemy. Therefore, we do something to eliminate the destruction. Or if our crops are overrun with weeds, again the damage is obvious. So we step in to correct these conditions. But few of us realize that this plant might just as well have been destroyed by grasshoppers for all the food value it contains. Few of us recognize that this pasture is almost useless as feed, for like that plant, this pasture grows on mineral-deficient soil. We've been fooled by the size of the crop, by the yields per acre. Only now are we learning that even big crops may bring troubles in the breeding and the growing of our livestock. Mineral-deficient soils simply cannot produce good
food. Sorry about that. I cut it off a bit early. Let's jump out of there. Right. Here we go. Just jump out here for a second. This is US data, but it's interesting to reflect upon. You know, the US is a relatively young continent compared to our own, but this is the decline in foodborne nutrients per gram since 1900 up until recent times. So there's been a big decline in the amount of nutrition coming through in the food that they've been measuring over there. At the same time, we've seen a big increase in the rates of our major diseases, whether it be things like cancer, obesity, bone deformities, heart conditions, asthma. Tinnitus is a very common malady that people face. So, sorry, I've doubled up on that. So when you start looking at some of this data, it makes you wonder about, you know, whether us as farmers can take an opportunity to not only improve our productivity and our profitability, but also capitalise on that by providing people with a more nutritionally rich food. And people are wanting to pay for that now. We've got modern technology, modern communication. People are becoming more and more educated and you know, perhaps self-educated, which could be dangerous at times. But there's a greater awareness that people are looking for better quality food these days, and they are looking to pay for it, but they're not sure that they're getting it currently. Quite a few years ago now, this is my youngest son. Anyone who's got a parent, who's been a parent will know that if you walk into the kitchen and the fridge door is open, there's a fair chance there might be a little person behind it. And here he was behind the fridge door at the time, and he was directly eating the butter straight out of the tin. And he had no discernible palate at that age. He was only 3 years old, I think. He had no understanding of you know, what he should or shouldn't be eating. He just knew what he wanted, and at that point in his life, he loved butter. And there's other examples of these cravings as well that we're all familiar with. So this is my neighbour's dog. This is a load of grain that I was taking out to feed some steers that we had at the time. And I turned around and here's the neighbour's dog gulping down this grain, looking for the energy to come out of that grain. He was desperate to eat it. I've never seen a dog eat a mixed grain ration like that was meant for cattle before. And then you've got these two characters here. They were over in the US at the time, and they'd had probably a couple of late nights in a row and were looking for some fast fuel for themselves. And then there's always the old isn't stressed spelt backwards desserts argument as well. So we have these cravings, and it's about understanding why these cravings might be present, and then starting to put some reasoning behind why those things may or may not be there. One of the areas that I started out in, majorly doing a lot of research work on with animals and animal nutrition and trying to understand why some of their cravings might be present, was looking at things like copper and iron in animals. Some of you may have even been diagnosed with hemochromatosis previously in your life, which is a build-up of iron in the blood that shouldn't be. And in cattle, if we have an imbalance with copper and iron in the body, then we can have an underlying anemia. They're much more likely to get every parasite known to man, and particularly things like worms can become an issue. Their immune system tends to be run down. So we started doing this research work trying to understand in this particular herd why a lot of their cattle looked textbook copper deficient. And what I mean by that is in cattle, if you have a copper deficiency, the hair coat on those animals will be dull. It'll be long hair, it won't be short. It's not shiny, they're not glistening. In dairy cattle, I always used to talk about cattle being brown and grey and not black and white. Even in beef cattle, you'll see around their brisket, they'll get this reddy, rony colour to their brisket, even if they're, say, Black Angus cattle, for instance. Because of this copper deficiency, they can get alopecia, which is a hair loss around their eyes, as an example. In young cattle, they'll get ringworm because copper helps prevent fungal diseases in the body. So we were trying to understand why those particular animals in this herd look like that. And so the first thing we did was we took some blood tests, and I was absolutely convinced all we had to do was give these animals some extra copper. And at the time when we did the blood tests, here's the copper tests here. The copper ideally would be 9 to 20, and you can see in actual fact, not only were they all 9 to 20, but in actual fact that cow there was quite high in copper. And someone said to me, listen, that's not how you test for copper in the body. It's not very accurate. The best way to test for it is to do some liver biopsies. And so we asked a vet to come down who had done some liver biopsies before. No one in our area had ever done them. And I don't know if anyone's ever seen them done before, but they have to give the animal a local, and then they have to cut through and create a hole so that they can punch a really big needle right through all the tissues and then into the liver and take a sliver of liver out. And they assure me that the cattle don't feel anything, but it looked very uncomfortable to me when I was watching the cattle being done. But long story short, we tested all these cattle for liver copper levels, and all these H's mean that they were very, very high in copper. So even though we were looking at these animals that looked hairy, they were stunted in growth, they had all the hallmarks of a copper deficiency, all the tests told us at the time that we had, in actual fact, too much copper in the system. And I went away and sulked for a little while because I really couldn't rationalise that. I didn't know why that was occurring the way it was. And I then started to do quite a bit of research. In fact, in the human population, I found that the same thing can happen. We can have copper build up in our tissues. It can show up in places like the eyes. You can develop these Kaiser-Fleischer rings where you'll get a copper deposition in the eye tissue. You can see a change in colour. So you can all look closely into each other's eyes tonight and assess that. Sometimes you'll see this brown ring around the outside. In the cattle, we were losing the hair around the eye. But it wasn't until I did quite a bit of reading that I realised that when the animal takes in iron, it absorbs the iron, it goes to the liver, it gets stored away in a storage protein called ferritin. And so it's a bit like stashing that iron away in the cupboard, if you like. And then what we want to do is we want to take that iron out from the cupboard and we want to make what's called hemoglobin out of it. And from hemoglobin, we can carry oxygen around in our red blood cells. That's what gives us our aerobic fitness. If any of you are starting to yawn tonight and get a bit tired, I apologise. But also, you're struggling with your aerobic fitness. You're not carrying quite enough oxygen around in the body. And so you start to try and take in a little bit more oxygen, particularly if we had some carbohydrates for dinner, because we're trying to get a bit more oxygen in to allow us to utilise those things. Copper plays a really powerful role in this process. The utilisation of that copper is via a protein called ceruloplasmin that we make from copper, and we make that in the liver. And then we have a adrenal hormone called adrenaline, which you all know, our fight or flight hormone, which has to be produced in enough quantity to tell the liver to make this ceruloplasmin from copper and then release the iron from the cupboard, so then we can carry enough oxygen around in our red blood cells. If we don't do that, we eventually run out of storage spaces, and then the iron becomes free in our blood, and that's when it can start to build up, and that can encourage bacterial pathogens in the body. And obviously, one of the issues was it then could be hemochromatosis. So understanding that mechanism is a really crucial piece of the puzzle, and it explained why the copper was building up, because the liver function in these animals was very, very poor, and we were missing in particular quite a few B group vitamins in these animals. The B group vitamins in the pasture won't be there in numbers unless you have a good enough uptake of boron into the plant. And boron's an anion. It's not attracted to the clay in the soil. It leaches. And so if we're deficient in boron, then we could lower the B group vitamin coming through in that pasture by 60 to 120%, which means then subsequently that the animals won't have enough of those B group vitamins and that liver function can be affected. So these are really critical pieces of the puzzle. One of those B group vitamins that the animal can actually develop themselves is B12, and B12 is developed from cobalt, and a lot of you would have given your animals some cobalt in the past, perhaps, to try and supplement them. But cobalt's very, very important in the soil. It allows the free-living bacteria called Azotobacter, also the rhizobia associated with our legumes, to fix nitrogen in the soil, as an example. It also prevents the plant from spending one of its main amino acids, methionine, and converting it too quickly into ethylene, which is the maturity hormone. So in other words, it slows down the maturation process of our crops so that they don't go to head and they don't finish too quickly. Gives us a bit more time to supply nutrients and fill the crop at the other end. So cobalt's really crucial, and if we're giving it to our animals, then there's a bit of a clue there that we might be missing it ourselves. This particular lady here was ready to go in for a cesarean. She'd been in and done an iron study on her blood with her local doctor, and on the November that year, her iron should have been between 10 and 30, and it was at 15.6, and then by the following March, it had dropped down very low to 5.7, and she wasn't able to actually go and get the cesarean done until they could bring it back up again. And so the doctor gave her some iron to take, and she and her husband contacted me, and I suggested she might want to take some B group vitamins and some choline, which is otherwise known as lecithin, at the time, and some beetroot juice, because beetroot juice contains betaine, which is one of the cofactors that allows the liver to start to function much more effectively. And the doctor said to her when he was presenting her with her next series of results, look, don't expect to see too much, but as long as that iron's risen a little, we'll be very happy with that result. And it had not only risen a little, it had risen a lot. It had gone from 5.7 up to 19.6 because it was starting to become available. But the storage sites had also filled up as well, because she was given a large quantity of iron all in one go and didn't need that much. She just needed some cofactors to go with it to make sure that that was more effective. Just in cattle, a couple of before and after photos. Some work I was doing in New Zealand with one dairy herd over there. They were really struggling to make any money until we had a big impact on their animal health by giving them the vitamins and minerals that the animals required, and we were simultaneously working on the plants as well. But we saw a 45% increase in production in those animals in a very short space of time, just by making some changes. An Australian dairy herd over here, up at Goldilocks. These guys got burnt out last year in the fires, but up there near north of Bega at Cabargo. But these were the same group of animals but split. So these were the earliest animals, so they're normally the healthiest animals to come out of the calf sheds, but had no minerals. These were the animals that had minerals. So you can see, a vast difference in those animals. When you look at the interaction of the minerals in the body, in the plants, there's a real both synergy and antagonism between minerals. So it's something that we've got to keep in mind. And I always explain to everybody that we've got to understand how this whole basis of energy within the body is produced. So within the body, we've got billions of cells. In each of those cells, we've got these little organs, and one in particular that we spend a lot of time trying to understand is the mitochondrion. And in the mitochondrion, we've got this process taking place called the Krebs Cycle. And I won't bore you to death with all the chemistry side of things, but it's basically where we take in our fat, our carbs, our proteins. We make one main fuel out of them. But you'll see here, there's a whole bunch of B group vitamins that are required in this process. And then we've got some spark plugs that take it from one stage to the next. So we've got cysteine, which is a sulfur-based amino acid, some iron, some vitamin B3, some magnesium, some manganese. Sometimes when you get deficient in one of these, and the same thing happens in the plant, you will start to pick up the other one in excess, potentially, because you've got a deficiency of one of these others. Some more B group vitamins. Down the bottom, you make energy, which is ATP, after you bring in oxygen and take some hydrogen off this cycle. But as a byproduct, we also make what's called free radicals. So I just want to give you a little bit of background on these little bits and pieces, because this is important in terms of some of the health issues we're trying to assess at the moment for everybody. Free radicals are oxygen species that don't have enough charges attached to them. So we've got two here, and only one here. And he's looking to pick up another charge, this guy. And I tell everybody he's a bit like a spoilt child. If he doesn't have what he wants, he'll go and take it and not ask permission. And he'll come along to your cell membrane. And your cell membrane's made up of parallel lines of fat cells. They all contain these little charges. And here's this free radical, and he says, "You beauty, I'm taking yours." This guy says, "Well, hang on, I needed that." So he says to his mate, "I'm going to take yours, I'm going to take yours, I'm going to take yours." So we start this chain reaction. We start to break down the cell membrane. If that's our skin, you can imagine over time we'll start to get wrinkles. If it's our eyes will start to break down. Our hair might start to go grey. Our joints might start to give us some grief over time. So I tell everybody, we call it aging, but we really should be calling it what it really is, which is free radical damage, and everybody would take a lot more notice. Other ways that we might have free radicals forming in the body, apart from just the natural byproduct of our main energy cycle, if we had an excess of copper or iron in our bodies, that could create this reaction, which would create more free radicals. Then if we were exposed to drugs or chemicals, even if we just had to take a Panadol, we've got to break it down through our liver. That could create some more free radicals, potentially. And then finally, if we have anything foreign out there, we're going to send out our white blood cells, which are the army, to try and hunt down the foreigner that's out there. And they're going to fire off a whole bunch of ammunition at whatever that foreigner may be. And the ammunition they're firing off are free radicals. You can imagine, if that's fungal or bacterial or topically viral, excuse me, any of those things have cell membranes and can be destroyed by the white blood cells, which is great. That's what we want. But what about if it's, say, heavy metals in the body, or maybe it's sugar building up, glucose building up in the blood that we're not utilising very effectively? It could be an excess of nitrogen even in the blood if our liver is not functioning as effectively. It could be too many response to stress hormones in the body that we're producing because we're under a bit of stress. Any of those things can attract the army, and they'll be out there firing away with ammunition. And when they do that, those things aren't alive. They are not an entity. They don't have a cell membrane. So what gets damaged is us and our own cell membranes. And so we start to leak fluid out in the tissues. It feels like we're on fire, which is why they call it inflammation. Anything ending with itis is to do with that process. So, excuse me, why don't we just have the body breaking down? Well, it's because we've got a defense against these things. And the same thing happens in the plants as well. Excuse me for a second. We can take in some antioxidants, so things like vitamin A, vitamin C, vitamin E. They will donate electrons back to these free radicals, and they turn them into water so that they're completely benign and can't do any damage to our own cell membranes. But as you saw earlier, the level of these nutrients in the food that we're growing are starting to become less than what they were. And if we're looking at things like vitamin A, vitamin C, vitamin E, if we don't have enough copper, enough manganese, enough magnesium, enough boron coming through into the plant, then we'll see a significant drop-off in the number of these nutrients coming through into the plant. But the body's pretty cool. We've got this backup system that we can utilise, and we can make some antioxidant enzymes ourselves. So we can make what's called SOD, we can make catalase, and we can make glutathione, which is the master antioxidant in the body, and we make that in the liver. But in order to make those, we need a whole bunch of minerals. So we need manganese, copper and zinc to make SOD, we need iron and copper to make catalase, and we need selenium to make glutathione, the master antioxidant in the body. These are really crucial, and if they're dropping off in our food supply, then it's something that ideally we would be aware of. If we want our immune system to start responding, we also want to make sure then that we can slow it down and stop the damage that may be occurring in the body. And that's where these antioxidants are really crucial. The other thing that's really, really important there is what's called our adrenal glands. So our adrenal glands are on the top of our kidneys, the top of our lower back there, and they produce our anti-inflammatory hormone called cortisol. And the job of that guy there is to tell those white blood cells, hey, back off, calm down a bit. It's like calling the dogs off, just settle down. In order for us to make enough of these adrenal hormones that we produce in the body, we need a really good supply of magnesium, and we need a really good supply of B group vitamins. A guy called Dr. Andre Bison did a lot of work looking at the adrenals back in the 1970s. He was a veterinary biochemist and a really incredibly interesting guy. And he discovered that if the cattle ran out of magnesium, and if we run out of magnesium, we need magnesium to relax our muscles. If we run out of magnesium, we start to get stiff and sore muscles. We start to get muscle cramps, jumpy legs, twitchy eyelids. The neck and the back might pull out at times. You spend an hour on the tractor and haven't been on the tractor for a while, and the next day you've got a really stiff neck. You'll have trouble sleeping right through the night. You'll wake up at 3 or 4 in the morning and can't go back to sleep. They're all symptoms of magnesium deficiency. Andre Bison discovered that if we started to run short of magnesium, our adrenals would try to overcompensate. They would swell and then they would collapse. And we don't want that to happen. That's really, really important. Another nutrient that's really important in our immune system is calcium. And this is the uptake of calcium into an immune cell once it gets activated. This is some work done in cattle, but the blue level is a very low level of calcium in the white blood cell itself. And then you can see within 35 seconds of these cells being activated, as the immune system gets activated, they've taken up a huge amount of calcium into the white blood cells. So having an adequate supply of calcium in our system, not only important for our teeth and our bones, but it's also really crucial for our immune system. And I'm going to show you a little bit on cell wall strength in plants, and the same thing goes for us within the body as well. Right, just want to show you this quickly. This was some work done having a look at lowering inflammation in the brain of animals and seeing whether it improved their memory or not. So we'll just put this up for a second.
So we could collect simply the soluble fraction of blood, which is called plasma, and inject it either young plasma or old plasma in these mice, and we could reproduce these rejuvenating effects. But what we could also do now is we could do memory tests with mice. As mice get older, like us humans, they have memory problems. It's just harder to detect them, but I'll show you in a minute how we do that. So but we wanted to take this one step further, one step closer to potentially being relevant to humans. I'm showing you now as unpublished studies where we used human plasma, young human plasma, and as a control saline, and injected it into old mice and asked, can we again rejuvenate these old mice? Can we make them smarter? And to do this, we use a test. It's called a Barnes maze. This is a big table that has lots of holes in it, and there's guide marks around it. And there's a bright light that's on this stage here. The mice hate this, and they try to escape and find the single hole that you see pointed at with an arrow, where a tube is mounted underneath where they can escape and feel comfortable in a dark hole. So we teach them over several days to find this based on these cues in the space. And you can compare this for humans to find your car in a parking lot after a busy day of shopping. Many of us have probably some problems sometime with that. So let's look at an old mouse here. This is an old mouse that has memory problems, as you notice in a moment. It just looks into every hole, but it didn't form this spatial map that would remind itself where it was the previous trial or the last day. In stark contrast, this mouse here is a sibling. It has the same age, but it was treated with young human plasma for 3 weeks with small injections every 3 days. And as you notice, it almost looks around, where am I? And then walks straight to that hole and escapes. So it could remember where that hole was. So by all means, this old mouse seems to be rejuvenated. It functions more like a younger mouse. And it also suggests that there is something not only in young mouse plasma, but in young human plasma that has the capacity to help this old brain.
Fascinating study. This is a severe Alzheimer's brain. You can see how much inflammatory damage has been done to that brain. So if we can prevent inflammation in the body by promoting all those systems that we've been chatting about so far, then we're in good stead for living a much longer, healthier life, much more productive life, and we'll remember it, which is even much more positive as well. I'll just jump out of there for a second. Right, so I want to swing over to the plant now, and I want to show you, some of the correlations in terms of how the plant works and why all these nutrients are important, obviously not only in us, but also in the plant as well. And all of you know that what we're really trying to do with the plants that we're growing is we're trying to capture the sun through the leaf and develop chlorophyll in that plant, which is then going to fuel that whole plant in terms of energy and the energy system. One thing I want to point out here is chlorophyll is a molecule that contains 4 nitrogens and 1 magnesium in the center there. And so sometimes we underestimate how important magnesium is in the system. We might compensate for nitrogen, but maybe not for magnesium. And so there's a really crucial link there, very, very important. When you look at the biochemistry of the plant. We won't get bogged down in this, but what I want to show you is that when we start with photosynthesis, it's occurring in 2 stages, but right at the very beginning, we're taking in some water and we split the water molecule, but in order to do that, you need some manganese. And I'm sure a lot of you are starting to do plant testing these days, and quite often you'll see manganese out of balance in a lot of plants that we test. And that manganese then gives all the charges that are needed to make the rest of the nutrients available all along the chain that help provide energy out of this process. So it becomes a really crucial piece right at the start. But once you start looking within the plant, you look at something like iron. You've got iron 1, 2, 3 times in the plant in this part of the process. You've also got magnesium in there 1, 2, 3 times. If you undergo wetter weather, and you're not going through that currently, but if you undergo wetter weather, then iron can become more available into the plant. As oxygen leaves the soil, iron can become a bit more available. And if it does so, then you need more magnesium to go with it to be able to utilise that excess iron. Otherwise, it's going to start to build up in the plant. And just the same as in us, if iron builds up too high, it creates free radicals. And we'll get to the stage with animals where they really don't want to eat that plant. They don't want to touch it because they know that it's going to make them feel not well either. So making sure that you balance that out with some extra magnesium can become really important. Other nutrients that are really critical in here are things like copper, zinc. You've also got sulfur in here twice, and quite often in the work that I do, I see a lot of sulfur deficiency in a lot of plants over time. If you're doing tissue analysis, quite often sulfur can be there but building up and not being utilised. It's stored as sulfate. So even though the soil's deficient, it can be building up in the tissues of the plant. But if you go and do sap analysis, quite often you'll see that it's inadequate. There's not quite enough sulfur there. Out of this process, the plant is taking in carbon dioxide, it's giving off oxygen, and it's making sugar. And some of you may have measured the sugar in the plants before by measuring, say, the Brix level as well. One thing you need to be a little bit cautious of is if you've got a deficiency of magnesium in the plant, you may see an elevated level of sugar measurable as Brix sometimes. So it's a false Brix, if you like. So it's important to know that. That sugar then comes into the top of this cycle, and you guys all understand this cycle now because we've been through this before on the human side of things. It's exactly the same, producing energy down the bottom, and then the energy then swings through and it comes into this cycle here. This is called the GOGAT cycle. The reason why I want to show you this cycle is because this is where we take in nitrogen, whether it's ammonium or nitrate. There's now a better understanding of amino acids coming through into the plant too. And even the plants picking up via the roots bacteria and stripping amino acids out of those bacteria as a nitrogen source as well. But if we just look at ammonium, for instance, ammonium comes in, and what we're really trying to do is we're trying to convert it into amino acids. And amino acids are the building blocks of protein. And that's what we get paid for in agriculture, is protein. High protein crops are challenging to grow, and understanding this process really helps allow us to gain some productivity in the system. So we're taking in some energy, we take in, say, some ammonium out of the soil as a nitrogen source, and then originally that ammonium gets converted into what's known as glutamine. That glutamine can then hopefully come around here, form glutamate, and then form amino acids and proteins. But if it doesn't continue around in this cycle, it starts to build up. And so the plant can't get rid of it. So if we get an excess of soluble nitrogen in our system, we can break it down via the liver and then excrete it out through our kidneys and our urine. But the plant can't do that. And so it has to try and convert it into what's known as asparagine and store it in the roots. If it does that, it's going to use up a lot of copper and manganese and some zinc. So if you continuously see these things low and you see ammonium high, it's telling you that there's some other blockages happening within the plant. So there's a few clues we can use when we do our detective work, trying to determine, how do we get some better productivity out of these plants. The first block in the system here is phosphate and magnesium. And phosphate can definitely be deficient, but quite often magnesium is. And so that can be a critical block in the system. Secondly, as we come around here, we need iron and we need sulfur. And so not always, but quite often we'll have iron, but sometimes we won't have sulfur either. And so once again, then we don't have this conversion right through to amino acids and proteins. And there's some really good data that's suggesting that if we don't convert ammonium coming into the plant, and also nitrate, and nitrate comes in and it goes through 2 stages, so it gets converted to nitrite by an enzyme called nitrate reductase, and then converted back into ammonium by nitrite reductase. So eventually it ends up back as ammonium and then converted into amino acids and proteins. There's some really good research showing that if we have elevated levels of ammonium and nitrate and nitrite in the plant, we're much more likely to get insect pressure and much more likely to see disease in the plant as well. So not only we're not going to get paid for having excellent quality protein at the other end, but we're more likely to get penalised, physically by a stress on the plant that it's creating. So having some of these bottlenecks removed is really important. When you sit down and draw out all the nutrients that are required sort of from one stage to the next, there's a lot. There's a lot of nutrients here, but you can test them these days. That's the beauty of where we're at in agriculture at the moment. We can go through and test these things. We can assess them. In broadacre cropping, you can actually address a lot of these things relatively cheaply these days through foliar fertilisers. And so there's some pretty good opportunities to not only grow some better quality food, but have a much more productive plant that's less likely to have stress upon that plant. You can see here for nitrate reductase, molybdenum is actually one of the main nutrients that's required there, but there's a whole host of other minerals that work with it, including boron that I was talking about earlier, that's critical for those B group vitamins as an example in the plant. When you look at other critical aspects of when we're trying to grow a plant as well, one of the nutrients that comes right to the forefront is calcium, because calcium is needed for cell wall strength, and it is in us as well. Just as an example, there's some, we know that vitamin D allows us to absorb more calcium out of our diet. Calcium then strengthens up the cell wall. A virus can't replicate unless it can get through the cell wall into the cell, and there's some pretty interesting research coming to the forefront at the moment showing that vitamin D seems to be a common factor with people who have less symptoms from being exposed to COVID, if you like. So there's some really interesting flow through from our health back to the plant health and then also animal health as well. Calcium builds up the strength in the plant walls as well, and it forms the glue in between the cells. So if we want a plant to grow, we need the cells to have lots of calcium and lots of calcium in between the cells as well. The other thing that goes in between the cells is boron. It allows the plants to make pectins, which are the glue that helps hold things together. So it becomes really, really important. And then we've got zinc. Zinc is crucial for cell wall strength, and I'll show you a piece on zinc in a minute. And then the last piece of the puzzle is silicon. Silicon is something that's not really considered a lot in mainstream agriculture, or at least it hasn't been. But in recent years, there's people starting to play around with silicon, trying to strengthen up cell walls and help protect against frost damage, for instance, in plants. Because you've got a flexibility, you've got a cell that is not going to be so damaged by the freezing process and then the thawing process. They're finding some pretty good correlations by using, say, potassium silicate as a foliar spray and strengthening up the cells. There's also some pretty reasonable evidence that it helps protect against a lot of fungal diseases as well. There's been a lot of research done in the States on that. there's silica in the soil, but silica in the soil is often part of the clay, and if the biology can get access to it, but if they start to do that, then the clay layers start to prematurely weather, and if they do, then it can expose aluminium that's within the clay itself. So some of the research work that we're doing at the moment is actually looking at applying silicon to the soil, so that it can then come through into the plant, and then obviously through into the animals and ourselves. Talking about zinc for a second, there was a really interesting bit of an experience I had on the South Island of New Zealand quite a few years ago now, where I drove onto this farm, and this guy had centre pivots so he could water all his pasture, and we were there on a Wednesday, and as we drove up the driveway, a lot of his pasture was all flopped over. It looked like it was completely dehydrated, and when I got to the house, I asked the owner, when was the last time that he'd irrigated that field, and it was on Sunday. So, we're only 2 or 3 days down the track, and he was looking like it desperately needed to be irrigated again. And one of the things that zinc does is it strengthens up the cell wall. It stops it from being so permeable. And if you have too permeable a cell wall, you can start to lose water through that cell wall. And so we create a water inefficiency in that plant. You'll also then lose nutrients as well. So this is an experiment where they had zinc added to the available to the roots versus no zinc, and these are the levels of. So here we've got 258 micrograms of zinc versus 16, and these are the nutrients that were leaching out through the roots. So we had 48 micrograms of amino acids leaching out through the roots versus 165. These are all the things that were going to make proteins that we were going to get paid on, and yet they were leaching out through the roots because there wasn't enough zinc there. Sugar, 375 micrograms versus, say, 751. A huge exudate of sugar coming out through the roots, and I want to show you something on that in a second. And then phenolic compounds which protect against fungal diseases in the plant naturally. 117 versus 161. This is a big issue, particularly this year on the East Coast, where we've got pretty moist year for the second year in a row. It's looking like fungal diseases are being pretty prevalent this year. And even potassium, it's the vegetative nutrient. It draws all the fluid into the cells, makes the cells expand and grow faster. 1.7 versus 3.7. If we've got all these nutrients leaking out through the roots, that could be a real issue as far as disease goes. Some of you may have heard John Kemp's podcasts, and in particular Don Huber, an amazing American plant physiologist being interviewed. And Don, I've met Don personally. He's a wonderful man, and he explains to John Kemp that in the soil we've got this process taking place called Fungiostasis, which is where we've got little fungal spores sitting there in the dormant phase where they'll do no harm whatsoever. And they'll leak out through their cell membranes themselves nutrients. So they'll leak out amino acids, fats and sugars. And you've got, hopefully, some little bacteria around here. And whilst they're consuming those nutrients, this guy will stay dormant and not get established. But if they're not there to consume these nutrients, at some point those nutrients will build up to such a high level that this guy will get going and he'll come over here and start infecting that plant. Well, if you've got leaky cells and you're leaking all that nutrient back out into the soil, we want some exudates going into the soils to feed the microbes, but we don't want a big buffet. If there's a big buffet, these little bacteria are not going to stay over here. They're coming straight over here, in which case this guy's going to get going. And we're much more likely to have disease being present from an early stage in that plant. Just to round out things, I just want to show you quickly some of the measurements that we've been measuring this year in plants. And this is some Sap Analysis done on wheat, and these are all the range of nutrients that we might want to test for. And that's 100% of what we would require within the plant. What I want to point out to you firstly is there's quite a few nutrients that are below the 50% mark in the plant of where they needed to be. And they include things like calcium for cell wall strength, boron, so critical for cell wall strength and for those B groups that we talked about in the plant. If we look at zinc, we're only just there with zinc. The other thing I wanted to point out here is that you've got an excess in what this grower determined as his bad Bennett wheat, because he had a terrible case of stripe rust, where he had a massive excess of iron and aluminium in particular coming through into the plant. They were coming through at toxic levels, and when they did, they created free radical damage to the cell walls. And so those cell walls lost strength, and so the fungal disease could get in. In the same paddock, he had this good wheat growing that didn't have any rust on it whatsoever. And you'll notice that they had much lower levels of iron, and in fact probably, to be fair, not quite enough iron in the plant, but a much lower level of aluminium coming through into the plant as well. And finally, one of our high protein crops that we get paid very handsomely for, this is really quite typical of a lot of canola crops that I see on the East Coast. And you'll see how low the nutrient status is coming through into some of these crops. Well, we've got very, very low levels. And this year, these guys have got a lot of moisture. So moisture is not the limiting factor this year. There's an opportunity to take these low levels of nutrients and grow a much healthier crop, much less likely to be diseased or less likely to be stressed, and to turn that into some significant money. But you can't do it without having an adequate supply of nutrients coming through into the plant. So I just wanted to give you guys a really quick run through tonight on some of the trends that are present there in human health, also seen in animal health, and with a better understanding of the interaction of these nutrients coming from the soil and by the biology and their work supplying the nutrients to the plant in the soil, we've got a much better ability then to create a much more robust, resilient, regenerative system that's going to feed us better quality food. And we're all going to make more money because the consumer wants to buy that quality food from us at the moment. I think it's an enormous opportunity. So I might just finish on that point there, Callum, if you don't mind, and we can take some questions if everybody would like to do that.
Yeah, no, that's been good, Pete. That's a good run and a good overview of that link between sort of plant health, animal health, and human health. So, yeah, has anyone got any questions on this one? Either punch them into the chat or unmute yourself and ask the question away. So I'll open it up for questions.
Thank you.
Hey, Pete, Robbo here, mate.
Robbo, good to hear you, mate.
Yeah, fixing excesses with SAP testing. So a few of us lads over here are doing a bit of SAP testing. Excess chloride.
Yep, yeah, good on you, Robbo. So, these are actually low chlorides, which is unusual because quite often we're measuring very high chlorides coming through. And you can even have reasonably low levels of chloride in the soil, Robbo, but it's still coming through in excess in the plant. Chloride's an anion. If it's coming through in excess, it's because you're missing one or more of the other anions coming through into the plant. It could be phosphate, but quite often phosphate's not too bad in a lot of cases. But the other things to have a really close look at is sulfur, but in particular also boron. When you start to get the boron levels coming up, Robbo, quite often you'll see those chloride levels coming down straight away. And it's significant. Chloride is only needed in very small supply in most plants. And if you have it too high, it's an electrolyte. So it draws the fluid back out of the cells. And that's not what we want for vegetative growth. So in order to get on top of it, having your boron coming through, if you haven't applied it to the soil, you can spray it out as a foliar. You can put, depending on your calcium levels, you can use Solubor is a really good product, and there's other products out there. But you can use it at up to sort of 800 grams per hectare, and it'll start to change things pretty quickly then.
Yeah, that's pretty interesting because it was an earlier test that was showing high chloride. Yep. And then obviously we have boron toxic subsoils.
Yeah.
When we did our last test, when our plants had rooted down into that boron,
yep,
our chloride levels had dropped.
Yep, absolutely, Robbo. Yeah, it's a real controller on chlorides. It's actually a big it's been something that I've been examining and trying to get to the bottom of for a long time now, because in dairy cattle, probably about 15 years ago, they introduced a technology to Australia, and at the time I was an advocate for it because we were selling. I was working for a grain mill and selling grain to the dairy guys in those days, but they introduced a technology called lead feed, and it was deliberately acidifying animals. And the reason why they taught us to do it was because if you acidify, say, a dairy cow just before she calves, it'll force her to try and draw down calcium out of her bones in order to rebalance the pH in her blood. And if she does that, then she's got available calcium for when she starts producing milk, and she won't tip over with milk fever. There's some really significant reasons as to why I don't do that anymore. It's not the best way to approach things. But what alarmed me is, so we got taught how to balance out the diet for the animals, and one of the most influential anions for acidifying the diet is chloride. So most nutritionists to this day will put magnesium chloride in the diet to try and stop the animals from getting milk fever pre-lambing or pre-calving. But I was noticing that we were seeing really low what they call, so when you balance out the positively charged minerals and the negatively charged minerals, it's called doing a DCAD analysis, a dietary cation anion difference. And I was noticing, going through the tissue tests on the pastures that we were working with during the season, a long time after calving, that we had these very low, if not negative DCADs coming through, and it's all driven by those chlorides, Robbo. So in other words, we were acidifying those animals all day, every day. And in a dairy cow, that's a disaster, because you need for her to build some calcium back up in her bone structure to stand her in good stead for when she might be potentially deficient. And so what was happening was that the longevity of those cattle was getting reduced. We were having cows break down pretty significantly by the time they got to 6 years of age because of it. They became very vulnerable. I remember one farmer had a cow fall over in the yard one day, and she broke a leg, and they had to put her down, and he gave it. He didn't want to waste her, and he gave it to a guy for meat for his dogs, and he rang him up and he said, "I've never seen anything like it. That cow's bone structure was like honeycomb. It was so brittle, all because of these excess chlorides coming through constantly all the time." So it was a real eye-opener to get to the bottom of why that was happening, Robert.
Oh, thanks for that, mate. Cheers.
That's a pleasure. No worries at all. Are there any other excesses you were thinking of apart from chlorides, Robert?
Sodium was another one that happened at the same time. So two excesses together at that point in time. I think that SAP test was taken around Zadox 31 type timing. Yep,
sure. So the levers on sodium are always potassium, which you guys probably have enough of, and calcium and magnesium. They're two really powerful levers, again, on preventing too much sodium coming through into the plant. And once again, you don't want too much sodium coming through because it's drawing the fluid back out of the cells, being an electrolyte. You want the potassium on the other side of the fence, drawing the fluid into the plant, not the other way around. Reverse osmosis, they call it. So you can hit those switches on it, Robbo, and that'll bring that sodium down pretty quickly as well.
Yeah, beautiful. Thanks, mate.
No worries at all.
Any other questions?
Yeah, Peter, just on that boron topic, like we've got boron subsoils as well, but often in our leaf tissue tests will end up like that are early on, it'll come up as low boron.
That's right.
And then within a month, when the roots get down into our boron toxic layers, they'll be showing boron toxicity symptoms. So just wondering, what we might be able to do about that. Or
good on you, Gareth. So early on, I think an early light foliar with boron could be beneficial for you guys before the roots get down into that zone. Once the roots do get down into that zone, one of the things that's really crucial in the plant is sap pressure. And we want to draw all the nutrients, obviously, from the bottom to the top. And boron creates that sap pressure. And if the sap pressure is too huge, then it'll break the cell wall once the water gets into the cell. And so that cell wall strength becomes really important in that situation. So whenever you have, an oversupply, if you like, of boron, there's been countless work that's been done on this and anecdotal work as well, is if you can supply that plant with additional calcium, additional zinc, and additional silicon, then it'll alleviate that boron stress in the plant, and you can carry that pressure. And ideally we want sap pressure, because when we've got sap pressure in the plants, instead of the leaves folding over, they stand up straight. And so we can carry a lot more leaves because we can capture a lot more sunlight and get sunlight down to all the leaves at once and promote chlorophyll in all those plants. But if you've got leaves that are flopping over all the time because we can't carry the sap pressure in the plant, then that becomes a physiological opportunity that we can change potentially. So if we can capture that boron but do it by building the cell wall strength, you guys have got a real opportunity to improve productivity. It's just a matter of finding products that are easy enough to work with. We're starting to apply silicon to the soil. It's a capital cost on a big acreage. It might be something that's a bit constrictive. You might just want to do some at a time. But there are silicon foliar sprays out there as well. The only difficulty with the silicon foliar sprays is they tend to be a bit nasty in terms of mixing with other things. So potassium silicate, it really doesn't like being mixed with anything else much, which means a separate run over the crop with it on its own. We've got guys playing around with some of the silicon fines at the moment in systems where they're running sort of much bigger nozzles. Some of these products are hard on the pump as well, but farmers are ingenious at being able to find ways of getting on top of things if they can get a productivity lift at a pretty reasonable cost. So agri-silica to a product which is a fine product that you've got to try and keep in suspension to get out there, but some of the guys have been playing around with that. But there's probably other silicon products that are in. I know there's one coming out of a company in Geelong that sounds pretty promising, and I'm sure there'll be others out there if we went searching wide enough for it. It's not something there's been a lot of awareness around, but I think it's a real big opportunity for you guys. There's no doubt about that.
Yep, thanks for that, Peter. Cheers.
No worries at all.
Yeah, Pete, there's a one that's come up on the chat function, and it's probably magnesium's been showing up as a real deficient this year for a lot of guys in their tests. But the question's sort of what form of magnesium and when is the best time to apply it?
Yeah, great question. Whenever it's deficient is a great time to apply it, is the first answer. As you saw, magnesium's just crucial. When you I'll just show you this for a second. This is iron, but magnesium. Sclerosis. Sorry, just open up this. Iron in plants. when you look at the role of iron and magnesium in chlorophyll production, this is a plant that's iron deficient, and you can see here we're at about 25 micrograms of chlorophyll being produced per milligram, and there's a plant that's iron sufficient. So we're up to 95%. So you've got a 70% difference in chlorophyll production in those plants. So you can imagine that's a huge difference in photosynthesis and exudates, providing nutrients for the biology, which are then providing nutrients back to the plant. So we've seen, playing around with some of those things, we've seen as bigger uptake as an increase of 50% in a lot of the nutrients once you get this chlorophyll production starting to improve. So, and magnesium, as you saw earlier, is absolutely critical for that. I was talking to Jared earlier tonight about some of the research work out in New Zealand is showing that if you have some carbonate in a soil and you have aluminium present, which is a lot of our soils, then that can allow aluminium to form what's called aluminium hydroxide. And aluminium hydroxide will then potentially form an insoluble salt with magnesium. So even though magnesium was there and present on the clay, ready to go out into the soil solution, it never made it into the plant because it formed this insoluble salt. Sometimes you'll even see it on the surface of the soil. You go out there and if you lick your finger and dip it into the salt, there'll be a bit of a crust there sometimes in some paddocks. If it's salty, then it's going to be, sodium most likely. But if it's not, it can be a bitter or almost a metallic taste, and it's this aluminium magnesium precipitate. In that case, then there's a couple of ways around things, but probably the most effective is once again foliar, and then we've just been using magnesium sulfate for the most part. Depends on your calcium level in the soil. If your calcium level's fairly low, we do come across some really low calcium levels as a percentage of exchangeable cations on the East Coast. Some of the crops we've worked with are down around 29%. That's very low in terms of calcium availability. I'd cut my magnesium rate back there because calcium and magnesium can be antagonistic. So I'd probably come back towards 3 kilos to the hectare of magnesium sulfate. But if we've got really good calcium levels, they're available in the soils, sort of up in the 60s. We'd take that up to about 4 kilos to the hectare. But it's one of those things you need to monitor with sap. It can be something you have to do fairly regularly. Especially if you've got that aluminium issue that I was talking about earlier. By the way, one of the reasons why you might want to think about investigating the silicon amendments to the soil is that silicon can tie up aluminium in the soil and then alleviate or free up magnesium. It also then frees up phosphate too, because that's the other thing that aluminium complexes with very readily. Is phosphate, and so does iron for that matter as well. So silicon can help alleviate that. So it's early days, but some of the work that we're doing, I think it'll gain momentum over time, potentially, if we can show that there's a significant enough productivity gain there at the other end.
Yeah, thanks, Pete. Just to add on to that, getting calcium in through the foliar, it doesn't play well with a lot of things, but have you guys come across a product that sort of plays well with other traces that doesn't require a sort of a single pass, so to speak?
Yeah, that's a really good question. I was actually, I was going to, some of you guys might have played around with Cal-X. I was going to ask one of you guys actually to see whether you'd mixed Cal-X and mag sulfate together. We've done it with calcium nitrate, and that's been okay. But it is difficult to get calcium to play well with sulfates. We're using sulfates because they're cheap. They're readily accessible. and once you start going to chelates, like it does add a fair bit of cost into the system normally. But a lot of the guys that I've been working with have been doing, we've been trying to apply a little bit of ground applied calcium as well. So I've been playing around with things like calcipril or 50-50 lime gypsum, but at lower rates to make it affordable for them, to try and alleviate some calcium coming through through the soil itself, if we can. Yeah, not an easy one. That's a good question.
Yeah, no, that's good. Couple more questions. You can probably see them coming up on the chat, Pete. So first one about spraying amino acids on crops.
We've done a lot of it by default by using fish. So fish hydrolysate is a cheap conglomerate of amino acids, if you like, and yeah, I like what I see when we use fish out there. But I've read a lot of research on amino acids being sprayed onto crops, and a lot of the research is very beneficial. Making it cost effective enough on a broad acre scale is very difficult. So I've probably more gone down this path of trying to understand how do we develop the amino acids within the plant itself, because I think that's a more rounded approach. The other thing that the emerging research is showing is that bacteria are playing a very big role in supplying amino acids direct to the plant, and we've got to do a lot more measurement, but I've seen, say, bacillus bacteria sprayed out, and you see this greening up like a nitrogen effect from them in many cases. So presumably that's coming through as an amino source. We know that they will go through the rhizosphere and through rhizophagy get into the plant. And, the plants can then strip the outer layer off the bacteria and get access to amino acids. So in terms of actually purchasing amino acids specifically to go and do it, look, there's definitely in the research there's lots of work that's been done. In fact, if you want to know more and you don't want to read any heavy, boring research, go and look up any marijuana grower's site, and I can tell you those guys know their stuff when it comes to promoting plant growth. And there's quite a few of them that have used amino acids to enhance plant growth. But I still think ultimately we want to try and understand the physiology of the plant a bit better and put some of these other things in, because they play, copper's required for amino acids as an example. So if you end up with a copper deficiency in a plant, one of the things that can happen is you get an overproduction of one amino acid called aspartic acid. And that promotes ethylene, which is the maturity hormone. So in other words, the plant starts to mature too quickly. And if it gets too bad, it can produce what's called anthocyanins, which is what gives that red colouring in the leaf at times. So rather than try and balance that out with another amino acid, you could go and put some copper in there. Now, copper is also required for what's called the phenolic compounds, which then protect against fungal diseases in the plant as well. So, that's. But if you want to play around with a bit of fish, there's some real benefits to using fish apart from just the amino acids. Very stimulatory for fungal growth. For instance, in the soil, we just spill a bit on the ground, leave it there for 48 hours or so, and you'll start to see some fungi growing on the surface of where you spill the fish. It's a really good fungal food, as an example. See, there was silicon in the sap is real interesting. Right, I want to show you. You can see it here in this sap analysis here. The plant. There's no doubt we need a base level of silicon in the plant, and It looks like it's different for different crops, given the work coming out of Holland at Nova. But in, say, wheat, for instance, it probably needs to be up around 37, 40 ppm. But in many cases, this is as a percentage of what it should be. In many cases, it'll be higher than that. And I can show you examples of where we've seen silicon coming through at, say, 120 ppm in the saps. Like, it's hugely high. But it directly correlates with the uptake of aluminium into the plant. The plant is trying to protect itself. When you look at some of the literature, they've shown that the plant will try and protect itself against aluminium toxicity by taking in some extra silicon. So sometimes silicon as an indicator can be a little bit misleading if we're only looking at silicon only. You have to look at, some of these other stressors on the plant, and particularly things like aluminium toxicity coming through. You can see here where the aluminium's high, the silicon's high. Where the aluminium's low, the silicon's much lower coming through into the plant. So I haven't fixated necessarily on an exact ppm of silicon coming through so far. I'm more focused at the moment on making sure that we're not really low in silicon. We're not around 5 or 6 ppm because we need it for cell wall strength. But at the same time, do we have an aluminium toxicity coming through in the plant? And that's a particular issue for us in our part of the world here, that's for sure. Was there another question there, Cal?
Yeah, there's one about moly deficient in sap in April, swing to excess by August. Do we apply?
Yeah, great question. Yeah, that's a really great question. If it's deficient, you should be applying. Very definitely, because it's needed for nitrate conversion. But at the same time, if it's starting to build up in excess, there can be a few reasons actually. So moly's needed for nitrate reductase, as we saw earlier. So we just have a look at nitrate reductase here for a second. You also need adequate levels of potassium. You need adequate boron. You need adequate manganese, sulfur, magnesium, and copper as well. So that's the first thing I go looking for. If moly's coming through in excess in the plant, then you don't apply it at that point. But you then go looking for what else is deficient. And quite often it'll be copper in particular, and it could be boron as well, in my experience. But copper, definitely, if you see an elevated moly coming through, you've very often got a copper deficiency. And if it's later in the crop, just be aware that that's a bit of a hallmark of a potential for fungal diseases if you get a more humid spring, because the copper is just so critical for preventing fungal diseases at that point in time, and for protein development. Wherever you want proteins in a plant, you've got to have copper coming through. Really, really important. But early on, if you are low in moly, go and have a look at the nitrate level in the plant. If the nitrate level is looking pretty handy, then that moly's all being used, to allow you to convert that nitrate through into ammonium, and then back into amino acids and proteins. So it's just a matter of understanding those connections and saying, right, I've got my detective's hat on now. Other times too, nitrate, if you've got an elevated moly, you'll go and have a look, and the nitrate could be quite low in the plant. You can see that's not the case here. There's where the nitrate's higher, the moly's higher. But sometimes you'll see an elevated moly and the nitrate will be really low coming through. And that signifies that there's not enough nitrification or conversion of ammonium into nitrate in the soil happening, which is a biological issue. You need two bacteria to do that, Nitrosomonas and Nitrobacter, and they need particularly copper, but they also need sulfur, boron, magnesium, really crucial for those guys, and some cobalt as well.
Yeah, that probably on that molly one, Pete. There seems to be a real trend this year that a lot of the tests are coming back low in molly, not just here but across into sort of Western Victoria. Is any reason why this year that's showing up particularly, or is it to do with the dry start and then the wet winter, or any thoughts on that?
Yeah, look, I don't really know. It probably is more to do with the dry start. The wet winter, if you've got the mollies allowing you to convert nitrate, that's coming from nitrification. If you shut down nitrification through wet weather, if you look at the nitrifying bacteria, let's grab this up for a second. Get down here. I call these nitrifying bacteria Goldilocks, because it's got to be just right. so if you have low soil pH, lack of oxygen, in other words, it gets waterlogged, lack of organic matter, dry soils, low soil temps, then you're not going to get maximum nitrification. So you're not going to have maximum nitrate coming through into the plant. The ideal is around 26 degrees C. Well, that's not going to be, at that time of the year necessarily. But then, so you can have low molly early on because you've got, before it gets too wet, because you've got plenty of nitrate coming through into the plant that's being used. But then if the nitrate shuts off, then that molly might start to build potentially. But as I said, the other thing could be boron as well. Boron's a cofactor. Boron leaches when it gets wet. So if you're losing boron out of the system, then potentially that could be it. And the other thing to look at is copper in particular as well, Cal.
Yeah. Okay. Another question there: how much cobalt should we be applying to crops, pastures, if we are giving it to stock via a B12?
Yep. So it depends on the level in the soil. There's some amazing work done by a lady called Nadia Gad. Any of you that can't sleep, that want to go to sleep, you can read some of her papers on Google Scholar. She's showing that total cobalt levels, which could be measured using a total test, should be around about 8 to 12 parts per million if you want to have the maximum nitrogen fixation happening in that soil, and that's a lot. That's a lot of cobalt, and cobalt's not cheap either, so it may not be practical on a broad acre sense. We on pastures quite often, if we're deficient in cobalt, we'll put out 500 grams in a year without thinking about it. I've put out much more than that, up to 1.5 kilos of cobalt sulfate per hectare. So cobalt sulfate's about 21% cobalt. In the cropping job, normally what we'll do is we'll just put it in the foliar, and you can do this with pastures too if you can't afford to go and put the cobalt out on the soil. When you go and measure in tissue analysis, you want to see the cobalt level around about 0.5 ppm. I'd have to look it up on the SAPs. I can't remember actually off the top of my head on the SAPs where it needs to be, but I can soon look it up. But you can put it in the foliar spray at 100 grams of cobalt sulfate per hectare, and that works really well, really well. It'll crash the nitrification rates in the soil, the nitrogen fixation rates in the soil if you don't have enough cobalt sitting out there. So it's a really important nutrient, much more important than people realise. And as I said earlier, if we've got crops that tend to be haying off too early or coming in too early, have have a look at measuring cobalt in those crops, and most likely you'll find a culprit there.
Yeah, okay. Yeah, it's one that's probably been not discussed much in broadacre terms. There's another question there, Pete. Can the fish emulsion be used as a chelating agent with sulfates to reduce crop burn?
Yeah, that's a really good question. It definitely, Jared would be able to answer that more effectively than me. I'm terrible on that chemistry side of things, but from what I've seen where we've used it, I haven't seen crop burn where we've used it. The other thing that we quite often add in there too is a little bit of kelp as well. Just a couple of layers of kelp per hectare, and that works. That actually increases the antioxidant capacity of that plant by about 620%. That works really well. With the sulfates, there's some guys that are doing, and I've not done it myself, but there's some guys doing making chelates using citric acid. So I don't know enough about it, but they tell me that it's working pretty well, creating a chelate that way. But I think you could probably use the amino acids in there at the same time as a chelation agent. But as to the rates and how you go about it, yeah, there'd be better people to answer that question than myself, unfortunately.
Yep. No, and I think we've probably got a couple more, and then we might just about have to call it a night, Pete. There's a question there. It's dry out. Well, basically, our soil moisture is drying out quickly. Plants are trying to flower and fill grain. Any nutrients that need to be we need to keep an eye on for both drought and frost?
Yep, definitely. So zinc is an important one, as we talked about earlier. Very important. If you're going into potential moisture stress, have a think about kelp. Like, it's something that a lot of people haven't played with, but it really does help provide a de-stress on the plant. Very important. The other thing that provides a de-stress on the plant is bacillus bacteria as well. So it's something that you might want to keep in mind there as well. And then cell wall strength is just crucial, obviously. So calcium and boron are the other two that are going to be really top of mind when you're trying to make sure that you've got a crop that's resilient and it's going to get through the finish line. That's for sure.
Yeah, no, that's good, and yeah, like you say, kelp's probably one that guys are starting to pay a little bit more attention to.
Yep.
Around the place as well. So, and just another tack onto the cobalt one question. So, cobalt on legumes.
Yep.
You scroll down, I don't see the whole thing. Increased nodulation.
Yep. Yeah, absolutely. We've had lupin crops in the last 12 months that weren't nodulating very effectively at all. Went and sprayed out cobalt. And moly if required, and straight away, the nodules started developing further, becoming beautifully pink within, and working for us. So it is that crucial, really, really important. It's a switch.
So does cobalt sort of go hand in hand with moly quite often, or not necessarily?
It can do, but it depends on which part of Australia you're in. Just as an example, if you go down to Tasmania, quite often they've got really excessive molybdenum levels, both in the soil and in the plant, but really, really low cobalt levels, like almost non-existent. So not always the case that they go hand in hand, but they definitely both work together for nodulation and for nitrogen fixation in the soil by even the free-living bacteria like Azotobacter, as an example.
Yeah. Yeah, no, that's good. Yeah, probably, and I sort of thought it was interesting discussion talking about animals and sort of particularly, well, my experience with cattle, and sort of when you were talking about sort of the coat colour and that sort of thing, because we had a line of Angus come through a few years ago, and the bloke walked straight through and he just goes, "Yep, you're deficient in zinc, copper, blah blah blah." And I said, "Well, how do you know that?" He said, "Well, look at the colour of the coat," and they had that tingy red, browny sort of look on their coat, and
Absolutely.
we put them on some mineral mix and give them 3 weeks, and those sort of those facial sort of warts, that sort of thing, and it just all cleared up, and it's sort of So I think we really underestimate the importance of balancing minerals out, not only in our plants but in the animals, and we probably should take it a little bit more serious about doing it in ourselves. So
absolutely, it can even affect an entire area culturally in terms of what they take on as an enterprise. When I got down here, I grew up with Herefords in New South Wales. When I got down here, there was very few Herefords, mainly Angus. And I said to my neighbour one day, "How come no one's got Herefords down here?" He said, "Oh, that's simple." He said, "They're all the wrong colour." And I said, "Oh, what do you mean by that?" He said, "Oh, they're all yellow. They're not that beautiful dark brown colour, so everyone runs Angus instead because they look so much better." And I tried to explain to him that it was a copper deficiency. But before I met my neighbour, very early on when I came to Gippsland, I was working at Wesfarmers for about 3 months, and I had 2 brothers come in. I had all this copper sitting on the shelf, these copper injections. And I thought, we'll never sell this in a month of Sundays. And within 24 hours, I had 2 brothers come in and buy every drop that I had. And it turned out later they were a very well-known family, and they had this neat little trick. They'd put cattle down on what's known as the morass country, which is sort of swampy sort of country that's very, very low in copper. And so they'd have their horrible, hairy sort of animals, and then they would inject them with copper a few weeks in advance of the sale, and they'd all shine up beautifully, and they'd get top dollar in the sale. So a bit of knowledge can be pretty powerful sometimes and very profitable.
Yeah, no, that's good. Well, Pete, I think the time's getting away from us. We might have to call that one a night. But look, thanks very much for sharing that information with us. It's been a great little walk through sort of that relationship between our health and what we're eating and what the animals are eating.